method of moment. Okay, method of moment. Again, is the same concept. Okay, that you already know during your mathematical statistics. Okay, we already highlight the definition. What is moment? Okay, so moment actually you have moment about the mean and also moment about the origin. Okay, so normally we use method of moment when it's quite difficult to use MLE to find the parameter estimation. Okay, but again, if you want to estimate something, if your choice whether you want to use MLE or method of moment. Okay, but sometimes it depends on the distribution. Normally when we have extreme value distribution, okay, ataupun extreme value density function, okay, normally we use method of moment. Okay, sebab agak sukar kita nak gunakan MLE sebab kadang-kadang dia punya parameter tu when we iterate dia ada problem lah, dia tak converge ke certain value. So when we use for extreme value punya density function. So normally if you have extreme value ataupun katakan kita ada extreme values in your data set, normally what we do for your parameter estimation is method of moment. Okay. So we have two types of moment that I already mentioned, method moment about the mean and also moment about the origin. Okay. So first we look at the formula for moment. Okay. So when we mention about moment, so that means you need to find your expected value. Okay, expected value of x to the power k ataupun to the power j. It depends lah, ya. Okay. So katakan you have a continuous random variable. Okay, so we have the PDF function. So the first k moment of x, normally we write is expected value of x to the power j, where you have j is equals to 1, 2, up to k. Okay. So you have your integration. So since this one is your continuous, so that's mean integrate x to the power j fx. Okay, depends lah what kind of parameter that you have. If you have one parameter, so fx theta. Katakan kita ada several unknown parameters, so you have theta 1, theta 2 and so on. Okay, kita nak estimate adalah dia punya parameter theta. Okay, so you already learn about your moment. Biasanya first moment is your mean. Okay, kamu punya first moment tu biasanya kita ada mean. Okay, so in this case you have expected value of xj is equal to 1 over n summation xi to power j. So katakan, let's say if you want to find your ex1. Okay, ex1. So that's mean kita integrate x, katakan fx theta. Okay, dx. Okay, so you have x fx theta dx. So again you have ex1. Okay, kita equate kan, sorry, ex to the power 1 bukan ex1. So this one you have here is ex to the power 1. Okay, ex to the power 1, that's mean x to the power 1 times your density function fx theta. So that's mean this one kita equatekan 1 over n summation xi. Okay, si, j dia satulah kalau kita dapatkan ex1. So katakan kita repeat dia punya proses ya. You want to find ex2, second parameter. So kita ada ex2. Again, you will have here x square. Then kita ada dx. So ini kita equatekan 1 over n summation xi square. Okay, kita akan repeat dia punya proses dia. Okay, so that's mean this one kalau kita simplify kan, we refer to definition 1.2. So if you have x1, x2, xn, a random sample, so katakan kita ada several parameter fx, theta 1, theta 2, theta k. Okay, so the method of moment will estimate your theta 1 hat, theta 2 and so on. Okay, So that means kita solve ni simultaneous equation, maksudnya secara serentak lah. So kita ada expected value of x, the formula is x, fx, theta 1, theta 2, theta k, 1 over n summation xi. So katakan kita ada several parameters lagi. Okay. So you need to find x square, fx, theta 1, theta 2 and so on. So kita ada 1 over n summation xi square. Sampailah kita ada katakan kita nak solve theta k. So you will have k equation which is x to the power k, fx, x, theta 1, theta 2, theta k, 1 over n summation xi to the power k. Okay. So katakan kamu ada dua parameter je. Okay. So that means you just solve this one dengan this one lah. So kita ada ex to the power 1, okay, and then kita ada ex to the power 2 and so on. Okay. So itu kalau kita ada dua parameter. So k kamu tu mewakili number of parameter. Kalau kita ada k equals to 3, so that means ex to the power 1, ex to the power 2, ex to the power 3. Okay. Itu kalau 3 parameter. So itu formula for method of moment. Dia tak ada likelihood function. Okay. Kamu tak adalah produk fsi theta. Tak ada L, tak ada ambil ln and so on. Okay. Cuma kita equatekan dengan kita punya expected value. So katakan expected value ex to the power 1, 1 over n summation xi. Ex to the power 2, 1 over n summation xi square. Katakan you have ex to the power 3. So 1 over n summation xi cube. Okay, kita integrate, kita samakan, setkan, dan kita selesaikanlah dia punya parameter dia. Okay. So katakan kita refer pada the first example, example 1.7 here. Okay. The density function is given as theta y theta minus. Okay, so this is your continuous random variable. Kita ada dia punya range dia. Okay, you want to find method of moment. Okay, kaedah moment. Okay. So again, you have theta y theta minus 1. Hanya satu parameter saja. Okay, so that means kita just selesaikan adalah expected value of y to the power 1. Okay, here you will have. So that means kita integrate y, darabkan dengan dia punya density dia, which is theta y theta minus 1 dy. So check your range is from 0 up to 1. Okay. Okay, selesaikan macam biasa. So that's mean you just solve your integration dulu. Okay, katakan here. So y theta minus 1. So y to the power 1 cancel out dengan minus 1. So yang kita tinggal adalah 0, 1. Kita ada theta y theta. Saya simplifykan dulu. Saya cancel out y to the power minus 1 tu. Okay. So solve your integration. So kita nak selesaikan integration with respect to y. So in here you just have theta over theta plus 1 y theta plus 1. So gantikan nilai 0, 1. Okay. So gantikan nilai y. So you just have here is just kita ada theta over theta plus 1 lah. So kita ada 1 gantikan over theta plus 1 is still 1. So just have here is theta over theta plus 1. So itu expected value dia. Okay, expected value of y. Theta over theta plus 1. Okay, so now kita nak solve kan. Okay, ini first step dia. First step, kamu selesaikan dulu. Sebab kita ada satu parameter je. So that means you just solve expected value of y. Okay, y multiply with your density function. Simplifykan, solve your integration. Okay. So second step. Second step, kita equatekan. So kalau expected value of y to the power 1, kita samakan dengan 1 over n summation yi to the power 1 lah. Okay, so 1 over n summation yi is the same thing if you write this one is your y bar lah. Kita sambung. Okay. So, saya tulis ni theta over theta plus 1 is equals to y bar. Okay, so you have theta over theta plus 1 equals to y bar. So, selesaikan kita punya nilai theta. So, you solve for your theta. So, solve for your theta. So, you have theta theta y bar plus y bar. So, selesaikan theta, simplifykan. So, you just have here is theta head y bar 1 minus y bar. Okay, so akhir sekali tu letak theta head. So, kita tahu itu adalah kamu punya parameter estimation. Jangan tinggalkan, jangan letak theta saja. Letak head dia tu. Head tu maksudnya anggaran, estimated value. So, theta head is equals to y bar over 1 minus y bar. Okay, so this one we solve using method of moment. Okay, so first step, find what is your expected value. Kita ada hanya satu parameter je you want to estimate, parameter theta. So expected value of y. Okay, ambil y, darabkan dengan density, selesaikan. Okay, so you have this one. So now second step, you equatekan dengan expected value of y, which is 1 over n summation yi. Okay, kenapa? Memang dia punya formula is just like this. Okay, memang caranya. Okay, so this summation yi over n is just your y bar. Okay, solve for your theta. So theta head y bar over 1 minus y bar. Okay, now kita nak dapatkan dia punya value. Okay, kamu dapatkan value. You compute your y bar, you already have your observation. Okay, so here we have 0.42, 0.1, 0.65, 0.23. So find your y bar. Katakan y bar, summation yi over n. So summation total up semua. Double check kamu akan dapat should be 0.35. Okay, total up semua divide by 4. You have 4 observation. Okay, and then replace balik. So theta head y bar 0.35. 1 minus 0.35. So give a this one. Okay, so ni kamu selesaikanlah ya. So give a value. So that is your theta head using the method of moment. Okay, kaedah dia mudah je. Cuma kamu equatekanlah dia punya dengan expected value dia. Okay, boleh ya? So this one. Okay, find your expected value. Okay, and then setkan first first parameter that you want to solve, expected value of y to the power 1. So it just have 1 over n summation y. And then selesaikan. Okay, so far example 1.7. Ada soalan? Okay. Okay, we proceed with the next one. Tak ada soalan, saya proceed next one. Okay, so you have this one. Kita ada theta exponential negative theta x. Okay. So this one pun kita ada dalam bentuk exponential distribution. Okay, exponential kadang-kadang kita ada dia punya rate parameter, dia punya scale 1 over. Kalau ini kita ada theta exponential negative theta x. Sebab exponential density function can be written in several ways. Okay, itu kamu kena aware lah. Kamu boleh refer balik for your reference. What kind of ways you can write for your exponential density function. Okay, so find the method of moment estimate and also maximum likelihood. Okay, katakan kita solve dulu guna MLE. Okay, we try for MLE first. Okay, kita ada theta exponential negative theta x, x greater than 0. So if you have your MLE, start by writing your likelihood function. Okay, likelihood function is just a product of your fxi theta. Okay, ini recall balik. So kita ada exponential distribution. So saya tulis L theta x. Okay, L theta x. So it is just a product I equals to 1 up to n fxi theta. Okay, so that's mean kita ada theta exponential negative theta x1, theta exponential negative theta x2. Sampailah kita ada theta exponential negative theta xn. Okay, now you simplify. Okay, simplify kan? Simplify kan apa yang kau dapat? So you have theta, 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 you have n times. So you should have theta to the power n. Bukannya n theta ya, theta to the power n. Okay, you have exponential negative theta x1, exponential negative theta x2. So altogether you will have exponential negative theta summation xi. Okay, likelihood function, make sure you get a correct way how you can write your likelihood function lah. Kalau salah kat sini dah salah semua. Okay, next step. You ambil you punya ln. Okay, kita ambil ln L theta. So you have n ln theta minus theta summation xi ln e. So ln e satu tak payah tulis. Then you differentiate. Step seterusnya differentiatekan ln L theta with respect to theta. So you will have n over theta minus summation xi. Okay. Setkan equals to 0 and then we solve. Okay, dapat apa theta head kamu? What do you get?
Satu per X bar.
Okay, betul. 1 per x bar. Okay, so that's mean kita solve kan. Okay. So kita akan dapat macam lah n over theta sama juga summation xi. Okay. So theta head kita ada n over summation xi. Tapi takkanlah kamu nak tinggal jawapan kamu dalam bentuk macam ni. Cantikkan jawapan kamu tu. So kita ada 1 over x bar. Okay. Sebab kamu dah tahu kalau summation xi over n, of course, your x bar. So find alternative way how you can write your solution. Okay. So supaya it more representable. Okay. So you have here is theta head is equals to 1 over x bar. Okay. So setkan likelihood function, ambil ln, differentiate, and then set equal to 0, and then you solve for your theta head. Okay. So that is your MLE. Okay. So now kita try for method of moment. Kita nak tengok sama ke tidak jawapan akhirnya. Ke berbeza. Okay. Sebab kadang-kadang for your own information when you derive using your MLE, it could be different from your parameter estimation method of moment. Mungkin berbeza. Okay, tapi both are acceptable. Okay, tak semestinya sama dia boleh berbeza. Okay, so that one you have to aware lah Okay. Sebab kadang-kadang ML itu is not unique. Okay? Dia ada dia punya way dia lain lah. Itu punya theta head tu. Okay, so that's why katakan kita ada theta 1 head daripada MLE, theta 1 head dia sekian-sekian. Daripada method of moment, kita ada theta headnya lain pula. So that's why kita comparekan dia punya variance dia. Which theta give you, which theta yang lebih efficient. So that's why after this topic, you will have your unbiased estimator, efficient estimator, consistent estimator. Okay, itu kalau kita nak verify kan. Okay, sebab tak semestinya ada satu je nilai theta dia. Okay, so that one is your MLE approach. So now you solve using your method of moment. Okay, katakan kita guna method of moment. Okay, kita ada this one theta exponential negative theta x. Okay, first method of moment saya tulis method of moment. So you have expected value of x. Okay, start by writing your expected value of x. So kita akan integrate x fx theta. So kita punya tadi theta exponential negative theta x. Your range from 0 up to infinity. Okay, yang diberi x greater than 0. So 0 up to infinity. Okay, nak solve this one, a little bit of using your integration by parts. Gunakan kaedah integration by parts. Okay, cuba dulu. Kamu selesaikan. Gunakan kaedah integration by parts lah sebab kita faktorkan theta kat luar. Okay, you solve x exponential negative theta x dx 0 infinity. Okay, use your integration by parts. So dapat apa tu? Dapat tak expected value of x? Dapat expected value of x?
0 ke?
Apa dia? Tengok. Siapa yang jawab tu?
Saya dapat 1 over theta.
1 over theta, betul ya? Okey, dapat tak yang lain 1 over theta? Yang lain dapat apa? Yalah, kamu gunakan integration by parts je. You solve kan? You should get lah 1 over theta. Boleh kah integration by parts? Dah final year dah ni. Dapat Okay. So saya tak tunjuk So I just simplify. So here you get expected value of x. You will get 1 over theta. Okay, good. So that's mean kamu bila jalan kerja tu kamu tunjuk je lah integration by part you do. So kita katakan u equals to x du dx dv exponential negative theta x. So dapatkanlah b kamu tu 1 per kan. So kamu ada negative theta exponential negative theta x something like that lah So selesaikan guna integration by part, you will get expected value of x equals to 1 over theta. So and then kamu solve kan. So kita dah tahu kalau kita pakai kaedah method of moment, kita akan samakan dengan summation xi over n. Okay, sebab hanya satu parameter je. So x to the power 1. So summation xi to the power 1 over n. So samakanlah dengan kamu punya theta. So dalam kes ni kita ada 1 over theta is equals to x bar. Okay, and then you get lah theta head is 1 over x bar. Okay. So this is your parameter estimation. So dalam kes ni dia punya nilai tu samalah kalau kita solvekan menggunakan MLE dan juga kaedah moment. Okay. Cuma kaedah moment Samakan dengan dia punya summation SI over N. Okay. Katakan soalan ni tak mention apa-apa. Katakan find the parameter estimation for theta. So you can try both ways lah. Sama ada kamu nak guna MLE ataupun method of moment. Kalau soalan tu dah specify use method of moment. Kalau guna MLE tak ada markah Markah guna MLE tak ada markah lah. Okay. Kalau dia specify guna method of moment, guna method of moment. Okay. Ini simple je lah Sebab kita dah tahu dia punya density function for exponential distribution dan kita tahulah dia punya mean tu apa, EX tu apa for exponential distribution actually. Okay.